Okay, looks like we're ready to start. Thank you for being here, folks. I know this is like the last bit of the conference. You know, I was kind of expecting 2 people, so I'm glad to see that I've got a few more than 2 people. So, my name's Martin Kearn. I'm from Microsoft. I'm an evangelist here in the UK from Microsoft. And I do a lot of work with web, with AI, and machine learning and cognitive services. And it's those last 2 things I'm going to talk about today. We're going to cover quite a few things around kind of the high levels of machine learning and also some of the cognitive services which are machine learning based APIs you can use in your applications. So before we start, does anybody recognize this guy? This guy, a Boffin. So this guy is called a Boffin. A Boffin is a person engaged in scientific or technical research, a person with knowledge or skill considered to be complex or arcane, a computer Boffin. Would anybody self-identify as being one of these? Like, are there any data scientists in the room? Anybody that likes to do mathematical algorithms and those kinds of things? Good, because sometimes I do this talk and people put their hands up and it's not, this talk is not for those people. So you guys are all muggles. You don't have the magic that Boffins have in terms of data science and mathematical machine learning algorithms. You just want to get to use machine learning, see how it applies to your applications and see what you can do with it, which is good. We're in a good place. So we have Boffins at Microsoft. We keep about 1/3 of them in Cambridge, in our Microsoft Research Centre in Cambridge, and we've got other Boffin pens spotted around the world. So most of our machine learning work comes out of our research labs, and one of the main labs that did a lot of the work with machine learning and cognitive services based in Cambridge, which is great. They've got this really lovely building in Cambridge. It's kind of custom built just for the Boffins there. Very beautiful, very serene environment. It's very academic, and they're all Professor something or other, and they've got lots of letters after their name there. In the walls of this building, they've got this scientific art. I've got no idea what this means and what this represents, but I'm sure that it's definitely something scientific. If anybody knows what this is, shout out, but I've not been able to find out so far. Possibly, it could be. It feels like it should be more scientific than that, though. It feels like it's like a bit more than just that. They've got a grand piano in the foyer there in the offices. So I work in Reading, and in our office, we've got an Xbox. And these guys have a grand piano. So, yeah, we work for the same company, but they're a very different breed of people, very academic. That piano was donated by Professor Andrew Blake in 2015 when he left the facility, as they call it, or the lab. So machine learning is a very academic world. It's a world of mathematics and algorithms and these kind of things, these long equations that you see written on their movies. And it can be quite scary. They do scary things in machine learning. So these words here, these are machine learning algorithms. So if you are a data scientist, you'll be familiar with things like support vector machines and artificial neural networks and those kind of words. And that diagram there, that's a machine learning diagram that represents one of those algorithms. So it's quite a scary thing. Machine learning is a scary thing. So if you're into this world of data science and machine learning, you are one of these Boffins. And for people that aren't familiar with that world, it's quite kind of scary to get into, and you kind of think, well, do I have to learn about all this mathematics in order to understand machine learning? And that's not true. So machine learning is for Muggles too, hence the title of the talk. This talk is about machine learning for Muggles. It's about how you can take all the benefit of machine learning and bring it into your applications without needing to do all the scientific stuff. And hopefully you guys are all Muggles, and therefore you'll get some benefit from this. So what is machine learning, just at a high level? So nobody put their hand up when they said they're a data scientist. A data scientist is a job role that's been around, certainly the last few years most prominently, but it's been around for a while. A data scientist is somebody that works with machine learning processes to understand data and get value out of data. And machine learning really is all about data. It finds patterns in data. So if you've got a data set of any size, really, it doesn't have to be big data. That's one of the misconceptions around machine learning, is that people think you have to have masses of data. That's not true. You have to have a decent amount of data, but you can do machine learning on something with just 20 rows in it. It doesn't have to be huge, big volumes of data. And machine learning will find patterns in that data, and it will allow new data to get insights based on those patterns. So if you think about a scenario of credit card fraud, if you've got 100 transactions and you know which ones were fraudulent from those transactions, they're historical transactions, if you know which ones were fraudulent, you can get a machine learning algorithm to figure out what the patterns are within that data set of 100 to make them fraudulent transactions. And then if you've got a new credit card transaction coming in, you can then compare it to that pattern and see what likelihood it is for this new one to also be fraudulent. And I use the word likelihood because that's an important thing as well. You're never going to get a black or white answer with machine learning. You're always going to get a likelihood or a percentage score. It's never going to be, this is definitely going to be a fraudulent transaction. It might be 99% sure, but it's never going to say it's definitely 100% a fraudulent transaction. It always gives you a score, and then you can use those scores in your applications to judge what you want to do with that information. So there's lots of use cases for machine learning. It's all around us. Whenever we've bought something on Amazon, we're using machine learning, the recommendation stuff that they've got in there. Whenever we play music on Spotify, who uses Spotify but just by show of hands? Okay, so about half the room. So you know that Discover Weekly playlist, the one that it seems to give you songs that you've never heard before from bands that you've never heard before, but you like them. And that's because it's machine learning. It's figuring out what you listen to, the music you normally listen to, and it's giving you something new that matches stuff that you normally listen to. Spotify do loads of machine learning in their apps. Most modern apps, most modern websites are full of machine learning. Dating sites are absolutely full of machine learning. Those matches, when they match people together, that's all machine learning based. So there's some common scenarios. So credit card fraud is one that I've outlined. There's an interesting scenario around predictive maintenance. There's some interesting Rolls-Royce with their jet plane engines do this. So most people don't realize this, but airplane manufacturers like Boeing and Airbus, they actually lease engines from Rolls-Royce. They don't buy an airplane engine. They don't own the engines that sit in their aircraft. They're actually leased from Rolls-Royce directly, and with that lease comes a maintenance contract. So it's Rolls-Royce's responsibility to maintain and look after those engines that are in all the airplanes that fly us around. Now, what used to happen with Rolls-Royce is they'd have a specific cadence for replacing parts and maintaining certain parts of the engine. And they'd say after so many flight miles, this thing needs replacing. After so many miles, this thing much like with a car, but in a much more complicated way because it's a much more complicated thing. And they found that they were maintaining things that didn't need to be maintained because they just had these fixed routines and schedules. They did some machine learning to actually try and predict when things were going to fail and actually be able to do proactive maintenance just before they're due to fail. So based on things like how long does that airplane fly? If it's Seattle to London, that's a certain route. It's going through certain atmospheric conditions. Where does it fly? Is it short haul? Is it long haul? What type of airplane is the engine fitted into? And all these factors come into predicting for that particular airplane, this engine is going to need that part replacing at this time. And they're able to just get in there just before that and save massive amounts of costs in terms of only maintaining when they need to based on the machine learning predictions rather than maintaining according to some fixed schedule. So that's predictive maintenance. We've got computer vision where computers can understand images and understand context of images. We'll have a look at some examples of that. Natural language processing where computers can understand speech and understand the intent and what's meant in the speech and what users are actually looking to get. So lots and lots of scenarios, and really any scenario where a pattern can be recognized in data is a scenario that could be used for machine learning. So if you've got some data, doesn't matter what it is, and you think there might be some patterns in that data, you can potentially use some machine learning algorithms to find out and give you some insight in that data that you won't be able to spot just as a regular human. So let's have a look at a scenario around car price prediction. So let's imagine that we're looking to buy a new car and we want to figure out how much should I spend on this new car. I've got a sort of criteria in mind. Those of you that have bought new cars, you've probably been through this process of I kind of know what I want, but I'm not quite sure how much I should be paying, especially if it's a second-hand car. So let's have a look at how we might approach that. Now, typically, so let's say we're looking for a car that's 130 brake horsepower. We're going to use a data set of 20 cars. We're going to go onto Auto Trade or eBay or some other place that sells cars and pick just 20 cars that are roughly about the same as the one we're looking at. We're only going to get price and brake horsepower data, so we're not going to get all of the data for every car. And we're going to do this without a computer. So we're going to look at a process for how a human might naturally approach this problem versus a slightly different way of thinking. So the way a human would naturally approach this problem is they'll take that data and they'll plot it on an Excel spreadsheet or a chart of something like this nature. So you're going to have all the brake horsepower for each car and then the price for each car. And you might look at that and we're looking for 130 brake horsepower here. So you might look at them and you might kind of say, well, these three seem like they're the closest match to the thing I'm looking for. I've only got the brake horsepower data to go on. So these seem about right. We've got 121, 142, 135. So you'll pick out those three and you'll say, well, the prices that are in those three cars, they kind of seem like it's about 20,500 thereabouts, just from looking at the data that I've got. This is the way a human might approach that. A better way to do this, a more scientific way to do this, with the same data, is to take those 20 data points and plot them on a chart like this. So you've got brake horsepower down the bottom, you've got price on the left there. Now each one of those dots represents a row in the chart that we just saw, but you can see straight away there's kind of a correlation here. There's kind of, you can see immediately how the brake horsepower affects the price of the car. And what you might do then is you might draw a line through the middle of that chart, and that gives you an axis that you can work on. Now we're looking for something that's 130 brake horsepower, so we might draw these lines, and that actually tells us with the same data that actually the typical price for 130 brake horsepower is 17,500. So our rough guess was £3,000 out. And using exactly the same data, we've only got 40 data points here, and we're not using a computer. Taking a slightly different approach, we're able to reveal a very different figure there. And you might draw a line around that and say, well, I'm looking for a range, and that might give you a range between 11,000 and 24. But you get the idea that by taking this is the way computers think. They'll look at the data rather than just taking a gut instinct, which is what humans tend to do. Humans are very, very bad at spotting patterns in data. We're not naturally good at doing that, but computers are. So imagine, though, if it was this data set. So this is car data as well, but we've got many more fields. We've got things like, is it a hatchback? Is it four-wheel drive? Is it a diesel or a petrol engine? What make is it? What model is it? What colour is it? All of these factors affect the price of the car, because a bright green Audi A3 is probably going to be less valuable than a gunmetal grey Audi A3. All of these things come into it, and all of these things affect the price of the car. So if we had maybe 15 data points and we had maybe a few hundred cars to compare against, there's definitely going to be patterns in that data, but it's not a pattern that a human can spot. As humans, we're never going to be able to see what the patterns are. We'll make assumptions based on preconceived ideas of what makes a car worth a certain amount, but we're never going to be able to spot the actual database patterns, and that's what machine learning is all about. It's all about spotting those patterns. So it's all about data. You have to have data. You have to have good data as well. You have to have good, consistent, clean data in order to feed into the machine learning processes in order to get those predictions out of it. Let's take another example and look at credit card fraud. And this is like this is like the 101 scenario for machine learning. Can anybody in the room spot, based on the data we've got on the screen here, what makes a fraudulent transaction based on what we can see up here? Just shout out if you can see it, yeah? Exactly, the name begins with the letter P. So is there anybody in the room whose name begins with the letter P? Good, we've got no fraudsters in the room here, we're safe. We're not going to get our money stolen. So based on this data, quite rightly, the gentleman says, the only thing we can assume there is the name begins with the letter P. That's not correct, is it? It's not a case that everybody whose names begin with the letter P is a fraud, so we haven't got enough data to draw a sensible conclusion here. If we have more data, though, yep, so there we go. If we have more data, we can actually draw half-decent patterns. So this is, again, a very tiny data set, but there is a pattern here. Can anybody spot the pattern based on this data about what makes a fraudulent transaction? Just shout out. There's 4 data points, 4 things that you can cause. Yep, just shout out if you can see it. Russia? So yeah, that's right. So they're in the 20s. What was it about Russia? It was used in Russia, the card used in Russia. Okay, yes, that's 2. There's another 2 in there. Issued in the USA, yep, that's 3. And there's a 4th data point here. Anybody spot it? The transaction amount is over £1,000. So we're a room of maybe 30 developers, like quite smart people, you'd like to say, and it took us maybe a minute to extract those rules. So yes, so it's over £1,000, issued in the USA, used in Russia, and the age of the person with the card is in their 20s. If a transaction meets those 4 criteria, there's a good chance that it's going to be a fraudulent transaction based on the data we have here. Now again, this is a tiny, tiny data set. This is not a real world scenario. You probably, to do credit card fraud, you would need many more transactions than this. You might not need many more data points though. These might be the only data points that you have available, and they might be good enough, but you might need more like 100 transactions as a minimum to draw a sensible kind of pattern. But the point here is that as humans, we didn't spot that. It took us a few minutes collectively as a room of people to spot what the patterns were. A machine spots that instantly. And using cloud processing power, you can spot that in massive amounts of data instantly as well. And that's where the value is of machine learning. So imagine if it was 10 million records, 60 columns. There's no way we'd ever spot that as humans, but machines can. So what's the process behind machine learning? So hopefully you're convinced that machine learning is a good thing. So how do you actually approach the problem and start to do machine learning? Well, there's a standard procedure. So you start off with data. You have to have data, as we've mentioned. It has to be good data as well. You can have multiple data sets. You don't have to have just one data set. It doesn't have to be some huge giant database. It can be just a CSV file or an export of some sort from some system. There's many, many formats. Whatever the format your data's in, you'll be able to use it in machine learning. And you also have to start with a question. So what's the thing that you're trying to learn about the data in this exercise? So in credit card fraud, we're trying to get some kind of a formula that allows us to predict whether a new credit card transaction is fraudulent or not. That's the question that we're going into it with. And you go through this process of cleansing the data. One of the things about machine learning, it doesn't really matter if you've got 1,000 or 998 rows. What does matter is that it's clean and consistent data. So if you've got any bad data, so characters missing, empty rows, empty records, any of that sort of stuff, you need to throw that data away. It's not useful in terms of the machine being able to learn the patterns. It needs to have consistent rows, consistent data that's all in the same schema, all in the same format in order to be able to learn. So we have this process called preparing the data, and we use data modules to do this, software modules that will identify where the data is bad and help us throw away that data or change it so that it's good data. And you would go through this process, a data scientist would go through this process of preparing the data. They might iterate a few different times until they come up with what's called a prepared data set. The next procedure is to apply a machine learning algorithm. So all those words that we saw in the chart at the start, the Bayesian neural networks, the linear regression, all those things, those are all machine learning algorithms. And these algorithms are mathematically, academically proven algorithms. They're not things that companies own. Microsoft doesn't own a machine learning algorithm. Apple don't own one. Amazon don't own one. They're mathematical equations that are proven and academically certified. And these algorithms get applied to the data. And they can learn things about data. These are the kind of rules by which the machines learn. And there's lots of different algorithms, and the algorithms can get applied to data. You might use multiple algorithms in combination to get to the data set that you need. And you iterate through that process again, and you end up with the thing called a candidate model. A model is basically the rule set. This is the output of the machine learning process. A model is the thing that your application uses to get insight on new data from the machine learning process. And you end up with what we call a chosen model. So this is when you've completed all the process, you're happy with the results, you have this thing called a chosen model. And your application will use that model, it will make calls to that model in order to, when it's got the new credit card transaction, it says, based on your model, what do you think about this? Is it likely to be fraudulent or not? The model will say it's 97% or it's 72% or whatever percentage it says. So in Azure, we have a piece of software called Azure Machine Learning, which helps you do all of this. So Azure Machine Learning gives you those data processing modules. So there's a load of different ways you can clean your data, and they're available as just software modules. You simply drag them onto your machine learning experiment, and they will do the work of cleansing your data. The machine learning algorithms are also available as software modules. So you just drag those on. If you want to use linear regression, you just drag that onto your canvas. You don't need to know the maths behind it. You don't need to know the science behind it. You just need to know that for this data, you need to use linear regression, which is a skill in itself, but we'll come to that. And finally, it will expose your experiment as an API. So your model, your chosen model, gets exposed as an API that your applications can call. So they can post in some data to it based on whatever the transaction is, and it will give back what's called a scored label, which is a percentage score of how well it answers the question. So the way they maps on, we've got the processing modules, the algorithms, we've got the API that sits between your application and the chosen model. And then underpinning all of this, we've got a thing called Azure Machine Learning Studio. This is kind of like an IDE for machine learning. It's a web-based interface that you can use to pull together your machine learning experiments. So let's take a quick look at that. I'm going to basically do the car price prediction thing that we just talked about, but I'm going to do it in machine learning this time with a computer and see how that comes together. So I'm going to start off with a mouse, hopefully. There we go. I'm in studio.azureml.net. So this is the place you go to. You can get to this from, just go to Azure and you'll find your way to this. I've already logged into this and I've already uploaded the data set. This data set is called car price data. So the screenshot of Excel that we saw a few slides ago, that's what this data set is basically. It's just a CSV file with a load of data about car sales in it. What I want to do is create a new experiment. So I'm going to go to New, Experiment. I'm going to use a blank experiment. There are lots of there's a whole marketplace for machine learning experiments, so people can upload their experiments and other people can use them or buy them even. We'll just start with a blank one, so you get the idea of how to build this. So the point of me showing you this is not necessarily so you can then go away and build your own experiments. It's just to show you that there's an interface. It's quite easy to use. It's drag and drop and how it roughly hangs together. So the first thing we need to do is that process of preparing my data. So this data actually has some errors in it. So let's just have a look at the data set. So I'm just going to take my car price data and literally just drag it onto the canvas here. With all of these modules, this kind of blob thing is called a module. With all of them, you can click on the output there and do visualize. What this will let you do is it will let you, as you're building up your experiment, it gives you a visual representation of the data. So we can see there's this column here called normalized losses, which has a lot of bad data in it. There's lots of empty cells there, so we don't really want that. We also might say, well, we can see the various makes and the fuel types and all the other bits of data in here. And as we scroll down, you'll see that some of them have got missing entries in there. That's not particularly good. So I want to do some cleansing work. You can see there's some with more missing entries in that one there. I want to cleanse this data. So there's two things I'm going to do. There's a module called Select Columns in Dataset. I just search for that. There it is. I'm going to drag it onto my canvas here. And the way this works is you connect these modules together. So I'm going to take the output of my CSV and make it the input to that select data one. If I click on that, I can do a column selector. I'm going to go to with rules, and I can sort of exclude, all columns, exclude column name. So I'm going to choose normalized losses. So notice how it's actually given me the columns of the data set. I haven't done anything to do that. It's just that it knows it's a CSV file. It's looked at the CSV file, and it knows that these are the columns in that CSV file. So I can just pick them. So I'm going to take normalized losses out. I'm going to take weight out as well. I don't want those things in my data set. If I now run this, it's going to do that piece of processing. It's going to clean up that data to that extent. So if we look at the visualize now, we'll see we've got no normalized losses column, and we'll see we've got no weight column as well. So we're starting the process of cleaning data, but we do still have these empty cells which we need to get rid of. Like I said before, it doesn't matter quite how many rows you've got. If it's got bad data in it, get rid of it is generally the rule. So this is bad data, and we need to remove some of those empty cells. So there's another module called Clean Missing Data, which I'm going to take and I'm going to drag into here. And just like before, I'm going to connect the two together. Now, there's various rules that I can set about how it cleans the missing data. In this case, I'm just going to remove the entire row. So this will basically mean that if it sees if any of the cells are empty, just get rid of that row. Throw that record away. We don't need it. So that's clean the missing data. I'm just going to run the experiment. You have to keep sort of running as you go along so it knows the latest thing. So what we're going to end up with, the output of that module is basically a cleaned, prepared data set. We now need to start applying some machine learning algorithms to it. So before we do that, one of the things that's important when you're building these experiments is to reserve some of your data for testing. So you'll use a percentage of it to actually learn from, and then you have another percentage to test that what you've learned is accurate. So what we need to do is we need to split our data set. And there's a module to help us do that, split data. I'm going to take the first output of clean data and put it into there. I'm going to say that I'm going to split 75%. So what this will do is socket number 1 will have 75% of my data. Socket number 2 will have 25% of my data. Okay. The next thing I need to do is add one of these machine learning algorithms. So you remember I said all these academically proven algorithms. The one that we want to use for this particular type of experiment is something called linear regression, which is one of the more popular ones. Now, the skill of a data scientist is really knowing which ones to use in which scenario. So I only know that it's linear regression because this came from a demo script and it said put linear regression in. I don't know what these modules actually do, but I know that that's the right one for this data set. I'm not a data scientist, I'm just a regular developer. So if you're going to get into this machine learning space, this is one of the things to learn is what the different algorithms are, what they do, when to use which algorithm in which scenario. But we know that we want to use linear regression in this scenario. The next step we do, and this is kind of where the main work happens, is we want to train the model. So we look for the train model module. I'm going to just place it there. So this takes two inputs. First, it needs some data, and then it needs an algorithm. So I'm going to take my data. So remember, that's the 75% of my data. And then I'm going to take the linear regression algorithm. And then I need to choose which column I want to train it on. So remember, we're looking for price here. We want a prediction on price. So the column I want to train it on is price. So I can just type in, make sure I'm doing this right, price. There we go. I don't want to. You could train it on multiple things, but we want to keep it simple and just train it on price. So that's the train model. We just run that. So we're now into the stage where we're actually going to start making some predictions. We need to now score the model and use that remaining 25% of my data to see how accurate it is, because I need to know that it's doing the right predictions. So we add in something called score model. There it is. So I'm going to take the output of my train model on one side of it, and then I'm going to take that remaining 25% of my data as the other side of it. So what this basically does is it says, you've used the 75% of data to learn about the data and come up with a prediction, and I'm going to test this prediction using the remaining 25%. So I'm going to take every field apart from price, see what the algorithm comes up with, and then compare it to the actual price, because the price is in this data as well, and see what the gap is, see what the rate of error is. That's the process of scoring the model. Okay. So that runs through pretty quickly, hopefully. Yep. So let's visualize what we've got here. So for each of these rows, we've got a price. So this top one is at 7957. And the scored label is basically the predicted outcome. So again, we're predicting price, and the predicted price is 8633. So you can see that they're all in roughly the same region. So this next one's 8499, and then it's predicting 7929. It's within 1,000 or there or thereabouts. This one's a little bit further out. This one's close again. This one's a bit further out. But we're in the right ballpark. The scored model is not a million miles away from the price for each of these cars. Of course, there will be some deviation. The scored model is never going to be exactly the same as the price, because it's a prediction based on all of the other data we've got. So what we need to do now is a thing called evaluate the model, which again we have a module for. We can drag that into here. And we can take that and push it into there. And we'll run this. What this will do is it will do that process, like I've just done manually, of comparing the price and the scored label price and seeing what the difference is. And it does it in a software way that is quicker than me going through every row and doing it. And this will give us a set of errors. Now, an error isn't a bad thing. It just means where the predicted price was different to the actual price, which is going to be the case in every single one of them. I mean, I won't go through what all these mean. The one that we're really interested in is this coefficient of determination. That basically means how far away, typically, was the actual price compared to the predicted price. And this is very low, and that's what we want. We want something that's very low. If the errors were huge, if the actual price was 2,000 and it was predicting 11,000, clearly something's gone wrong in the model. That's not a good prediction. But we know from looking at the data visually, and we know from this, that actually we're about right. So I'm happy with that now. I'm going to proceed with that and go on to the next stage. So the experiment itself is complete now. I'm going to save it. And what we have as the output of this evaluate model is we're at that stage now where we've got a chosen model. What I want to do now is publish this as an API so that I can start calling it in an application, start getting some data back from it. So we've got this button here called Set Up Web Service. I just need to run it one more time, I think. What we've done so far is what's called a training experiment. So basically, we've made an experiment that we can train the data on and come up with this model. What we're going to do next is turn it into what's called a predictive experiment, which is where we can apply new data and get some outcome from it. So we're going to go Predictive Web Service. What's actually happening under the hood here is we're creating an Azure App Service, and we're hosting a website, and it's actually going to get hosted as an API. But you don't need to worry about any of that stuff, because that's all abstracted for you by the interface here. You don't need to worry about virtual machines and servers and all that kind of stuff. This is a PaaS service, which means platform as a service. You don't need to worry about the infrastructure that sits underneath this. So that's my predictive experiment. I need to run that as well, which takes a little bit longer to run. And then we can just deploy this as an API and start making calls to it and see how accurate it is. It takes about 20 seconds typically to do this deployment. And this is one of the reasons why this has to work as a cloud service, because obviously there's a lot of computation that's going on here. Every time I click run, there's a huge amount of CPU work that happens. And to do this on-premise with your own servers, A, you'd have to have software packages to do that, which are very expensive, and B, you'd have to have a lot of resources to do that. That's why machine learning is becoming more and more popular now, because cloud enables us to do that as and when we need to, rather than having to invest in infrastructure. So let's deploy the web service. And it gives us this interface. So this is now an API. And you can see that I've got an API key there, which is just like every other API key. I can get rid of that. There's two ways you can call this. You can do it as a request and response, where I send it some data and it sends me a prediction. Or you can do like a batch execution, which is where you kind of stream data to it and it streams data back. We're going to just do the request and response. You can click on this to kind of see an API help page. So this is public. We can see that we need to post to it. That's the request URL we need to post. There's various headers that you need to pass in. You need to send some data to it. So what we're going to do is send some car data, which is going to include the make, the fuel, and all that kind of stuff. And it tells you what you can expect back. And it's a normal API. It uses HTTP response codes and all that kind of good stuff. We've got this little test interface, which is quite handy as well, which we're going to use now to actually test a new piece of data against the model. So I've got the details of a car here that I've got off AutoTrader. I'm going to enter that in and see what it predicts the price is going to be. So the make of the car is an Audi. The fuel is a diesel. Doors is 4. It's a hatchback. It's going to be front-wheel drive. The weight of the car is 1900. The engine is 150. The BHP is 150. The miles per gallon is 55. And the price of this car is going to be 23,000. Okay, so imagine a scenario, you're looking for a new car. These are the details of the car you're looking at. Let's see what the actual price should be based on the data that we've had. So we can, hopefully I'll zoom in so you can see that. So the actual price is 23,000. The scored label, i.e. the predicted price, is £20,900. So you can see there's quite a difference there between the actual price and what the price should be for that type of car. Which is, of course, you'd expect this because it's an Audi, right? So Audis are always a little bit more expensive than they should be, aren't they? Because it's an Audi. If it was a VW with this same spec, it would probably be closer to the actual price. But hopefully that gives you a flavour of kind of how we can learn from the data set. Again, it's a tiny data set really, but we've been able to learn sufficiently from it that we can predict the price based on all these factors that make up the car decision, and we can get some useful insight back from it. So that's the Azure Machine Learning service, car prediction price. So the problem with this, though, is it kind of is still a bit technical. It's definitely easier because you've got the drag and drop interface, you've got these nice modules you can drag and drop, but how do you know which modules to use? How did I know that I needed to use linear regression there and split data and train the model? It's a skill. It's not a skill that most developers have. It's something you have to learn. There's a whole breed of technical people called data scientists that do this for their job. So it kind of is still a bit for boffins. Those data scientist folks, they are a little bit boffin-like. You know, they do get quite excited about these algorithms and things. And it's not a skill that I particularly want to take on. I'm a developer, I'm a web developer. I don't want to be doing this stuff. So if you're in that category, this is where Microsoft Cognitive Services comes into it. Now, Cognitive Services is a set of APIs that we've built at Microsoft to help you add these kind of smarts to your applications without you needing to do the actual machine learning bit. We've done that for you. So there's a set of APIs that are built based on machine learning. They've built using exactly the same service that we've just used with our car prices. And they're exposed as simple APIs. So you can go and you can call these APIs in your applications just the same way you would do with any other API. And they're quite free, they're quite cheap. So for most cases, they're free up to a certain threshold. There's one that we'll look at in a bit that detects emotion in human faces, and that's free. I think it's up to 10,000 transactions a month. So that's not a trial, that's just free to use. If you're a small app or a small service, then you can just go ahead and use that. If you need to go over those thresholds, it's very cost effective. It's £1 per month. It's not It's not a cost prohibitive thing. It's a very affordable way to get some of those smarts into your application. There's a lot of them as well. There's 25 APIs in total, and across those 25 APIs, there's 66 different functions, 66 different API functions that you can actually call with your data. I'll just pick out a few of them. So computer vision is able to detect things in images. If you give it an image, it will be able to say what's in that image, what the colors are in the image, and all this kind of stuff about the image. We've got the face API, which can detect human faces and detect what we call face landmarks, so where your eyes are, where your nose is, where the end of your mouth is. There's 27 of these face landmarks. And it can do this because at Microsoft what we've done is we've taken millions of pictures of human faces, and we've had humans go and say, that's a nose, that's an eye, that's the end of somebody's mouth. Give that data to the machine learning process, and it's been able to then learn what an eye looks like and what a nose looks like. It's something we can do naturally as humans, but for a computer to do that is quite a thing. We've got speech APIs, so you can do speech to text and text to speech conversion. We can do we've got a thing called language understanding, which is where you can give it some text, it can understand the intent of that text, figure out which words are noise words and which words are the actual words that are important for the text. We can do sentiment analysis on text, so figure out how positive or negative some text is. There's recommendations API where you can do things like frequently brought together, all the stuff that Amazon tends to do. So there's a whole bunch of these APIs, and we're going to look at just a few of them. So let's look at a few of these APIs in action. Bear with me. Okay. So I'll start off with, are there any parents here? Anybody got children? Shall I show hands? Under the age of 5? Few? Okay, you're lucky. I've got one under the age of 5. She's called Madison, and this is Madison. So I think this is quite an interesting photo of Maddie. She was 3 when this was taken. And so I don't know what's going on here, frankly. She's got quite a strange expression on her face. I don't know if she's happy or sad. She's definitely not happy, but is she annoyed? Is she scared? Is she sad in some way? But fortunately, we've got a machine learning API that will help me determine what the emotional state of my daughter is here, and it's called the Emotion API. So if you go to microsoft.com/cognitive, you'll land here. This is the web page for cognitive services. These are all of those APIs that I just mentioned, and one of those is the Emotion API. Now, all of the APIs have this similar kind of interface. They have a page which kind of explains all the functions of the API. So this one can recognize emotions in images and also in videos as well. It can recognize 8 global cross-cultural emotions, and they are anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. So every human on the planet will at some point in their life display those emotions. Probably every day they'll display those emotions. And we've trained the machine learning process to be able to recognize what those emotions look like on a face. So they all have this kind of little sample app that you can use. There are stock images, but let's just upload that picture of Madison to try and find out exactly what's going on in terms of her emotional state. That's what's gone on there. Let me just refresh that. I think my browser's in the process of crashing. Let's try a different browser. Everyone can cheer at this point. There we go. Okay, so let's try and upload the photo to the website there. So what it's going to do is it's going to analyze her face, and it's going to see which emotions are being displayed. So the first thing that's good news is she does have a face, and what it's done there is it's given me a thing called a face rectangle. So it's given me the bounds of her face within the image. So in my application, I can maybe do something like that. I can maybe extract just that part of the image. I know where the face is. It's recognized where the face is in the image. What it's also done is it's given me her emotional state by way of a set of JSON scores. So we can see there that the overriding emotion being shown there is contempt. 58% of her emotional state is down to contempt there. So we can see the score there is 0.58 for contempt. We can also see that followed up with contempt is 20% anger, and then just a light smattering of disgust at 9%. So she's contemptuous, angry and disgusted with me at the point that that photo is taken. That's what happens when you tell a 3-year-old she can't have any more chocolate before bed. That's what happens. She gets contemptuous with you. So that's good. So that's helping me be a better parent. We're happy with that. The next website I want to show you is something called Twins or Not. Now, you may have seen this website before. Oops, that's going to get me to the right place. What this does is this is just a sample site we built that takes 2 pictures of 2 humans and tells you how similar they are facially. So based on their facial features, how similar are they? So I've been told in the past I look a little bit like Jake Gyllenhaal, you know, the American actor, the handsome American actor. I've been told I do look a little bit like Jake. So let's just see if we can find out whether that's true or not. So let's upload a picture of me. And then let's upload a picture of Jake, the handsome chap he is. And just see. So there we go. So according to machine learning and data science and all these good things, I'm 90% similar to Jake Gyllenhaal. We are in fact besties according to this procedure here. So it's able to take our 2 faces, look at our facial structures, all that kind of stuff, and determine how similar we are. So I'm really pleased with that. I do actually look like Jake Gyllenhaal after all. Another one we've got is called How Old. So you can imagine what this one is going to do. It's going to take a picture of a human face and determine how old that person is. So let's upload some pictures of me and Jake to this just to see. So I was 37 when that was just taken. And look at that, it's determined that I'm 39 years old. So I look 2 years older than I actually am, which is quite disappointing. The only good thing about this is that it has correctly identified me as a male. So yeah, I'm winning in some ways here, but I do look a bit old for my age. So let's try another photo, and let's just upload a picture of Jake just to see. So Jake is about the same age as me. He's about 6 months younger than I am. So he would have been 36-ish when this photo was taken. So let's just upload Jake, and just for comparison, there we go. He's 43 years old according to this. So Jake actually looks even older than he is than I do. So I'm quite happy about that, and I'm sort of feeling quite good about that. So that's a few little silly examples. Another example I want to show you is an app called the Live Camera app. Now this is an example app to show you, it's a Windows application to show you kind of how to work with these APIs. And what it does is it basically takes a picture every 3 seconds and uploads them to the API. So this is how we work with videos and video streams. So I've got a webcam down here somewhere. And I'm going to set it to camera 3, which is what this one is. I've got it on faces mode at the moment. So if I start the camera, it should hopefully start to figure out, there we go. So I look a bit younger now. I look 28 years old now. I'm not facing the camera, but I am a male, which is good. If I look directly at the camera, I can't see because I'm looking at the camera, but hopefully you should see facing camera and not facing camera. So I'm streaming these images there. What's happening every 3 seconds? This is taking a photo, sending it off to the Face API, getting the data back, and it's showing the results for us on screen here. There's various modes that we can do. We can look at emotions using the same thing. So what's my emotional state? I'm neutral at the moment. If I go like this, I can't see because I'm looking at the camera, but I hope that says happiness. If I go, that's surprise. So it's giving me, and you notice it's giving me a number as well. It's giving me how surprised am I. If we can also do tags. This is using the computer vision API. So what this is able to do is look at the images that are being sent up here and actually figure out what's being shown. So it's saying laptop, indoor, computer, electronics, which is right. We are indoor. That is a laptop. There's loads of electronics there. Let's look at the little Xamarin monkeys. Anybody got a Xamarin monkey today from the Microsoft stand? There we go. So that is a stuffed toy. A stuffed toy, a doll, in fact, is what that is. If we look down here, this is a bit of backstage for us there. Look at those. Those are hopefully bottles of water. So it sounds trivial because we, as humans, we know this, right? But for a computer to be able to look at these images in real time and actually say what it is. If we look at all you guys, it's blurry at the moment. There you go, conference room, a crowd. It's able to figure out what this is. Incredibly powerful stuff, really. So that's the computer vision API in real time using video technology. And like I say, the code for all this is it's all open source. So GitHub, go to GitHub, you'll be able to see how this is written and be able to build that kind of stuff into your applications. Another application I want to show you, a slightly more serious one, is actually this time it's an Excel application. Who knew that Office had an app store? Nobody. Nobody knows Office has an app store. It does have an app store. And you can have these things called Office add-ins, and they're basically apps that do things with Office. So I'm going to, I've got one called Sentimental. And what this one does is it takes any text that I put in Office and it can analyze the sentiment and figure out the sentiment and also the key phrases in that piece of text. So if I say, I really love London, especially the east of London. Help if I could spell. Hope if I could type and spell. So if I just select that cell in Excel, click Analyze, it's going to take that piece of text, send it up to the Text Analytics API, and give me some results. So it's determined that that's an 82% positive sentence, which sounds about right. It's determined that the key phrase in there was east of London. So although I've mentioned London twice, it's zoned in on the east of London because that's more specific than London. So it's very clever in terms of determining what the key phrases are. And then this app lets you kind of insert the score back into the spreadsheet. So can you imagine if, like, you guys will all hopefully provide some feedback for this talk, I'm sure, at some point, or the conference as a whole, you'll provide some verbatim feedback. Imagine if the guys that organise NDC could analyse the sentiment of that and figure out the key phrases of that and then insert it back into their spreadsheet. Very, very powerful stuff. We've used this internally at Microsoft when we do our own events. We run all the data through this tool so we can get a sentiment score for the feedback. Rather than just saying it seems like it's okay. We've actually got a score based on the data science there. And also the key phrases is really important as well. If somebody's complaining about something, being able to just pull out those key phrases is really useful because it just picks out the 2 or 3 words that are really key to what the complaint is, so you can get to the bottom of the issue quite quickly. So that's sentimental. So that's just a few examples of cognitive services in action. There you go, that's what Madison thinks. She thinks you can be a better parent of Microsoft Cognitive Services. Isn't that good? So let's look at another application that I've built called How Happy. So this is, again, it uses the Emotion API, but it uses another service called Lewis. So let's just have a quick look at this. You can go to this yourself if you want to. It's called, that's completely gone. I'm going to just use this, howhappy.co.uk. And what this does is it lets me uploads a photo of a group of people and determines who's the happiest, who's the saddest, who's the third most fearful, etc. Now, what I need to do this is a photo of a group of people. Now, you guys are a group of people, aren't you? So if you don't mind, well, even if you do mind, I'm going to take a photo. So look really happy, look as happy as you can possibly look. Okay. It's a bit blurry, so hopefully that will come through. Let's upload that photo to the website and see who's the happiest person. The lighting might cause us some problems here, but we'll see. So it's going to take that photo, it's going to upload it to the API. So we've found 5 faces, and the only reason it's not found more is because of the lighting conditions. But this lady here in the red is the happiest person in the room. Thank you for that. Well done. And who's number 5? This person over here is the least happiest of the 5 people that he recognised. So that's very good. So we can do things, so that's what that website's all about. It's about determining the happiest, the emotional state of the audience, and being able to rank who's the happiest and who's the saddest. So how does this work? So it uses the Emotion API. We've already looked at the Emotion API with that picture of Madison. It also uses a thing called Lewis, which is Language Understanding Intelligence Service. I'll show this in a bit, but you can filter and sort this API based on natural language queries, which I'll demonstrate in a second. And it's just built using ASP.NET and JavaScript. It doesn't really matter what it's built in. It's a web application. Hopefully you'll get the idea that this is completely platform agnostic. It doesn't matter whether you're writing Android apps or something to run on a fridge or a web application or whatever it is. It's fine. It's just an API. That's the whole point of this, really. So Lewis is an interesting one. So if I just go back over to the website here, I can do so. By default, it's sorted the 5 faces by happiness. That's the default state. But I can do things like who is the happiest one here? So this is a natural language, the way a human might talk to another human. Who's the happiest one here? What that's going to do is it's going to say we've found 5 faces, we're showing number 1. So it's determined that my intent there was not to show all of the faces, but just to show the happiest one there. I might also say, who is the saddest one here? So I might change the emotion. Same query. So we found 5 faces, we're showing number 1 for sadness. So who is number 1 for sadness? the person that was least happy, sorry about that. I hope it's not my talk that's making you sad. But the interesting thing there, I've asked the question using natural language, and I've changed what's called the entity. The emotion that I'm asking for is called an entity. Now, we'll dig into this a little bit more later, but one of the things that's useful here is that it's able to take general words and pin them down to the word that the API needs is happiness or sadness, and I've searched for happiest or saddest, and it's able to determine that those mean the same things. We can say things like, who is the third most surprised person here? So 2 things are happening here. So the third most surprised person, just in case you were wondering, it's that gentleman there again. There's two entities are being used here. The first one is what's called an ordinal, which is the number. So I'm looking for third. It could be first or second. I've written third. I could have written it as in THIRD as well. It would have meant the same thing. And also surprise is the other entity that we're looking at there. So what we're looking at there, the breakdown of this is these phrases are, who's the happiest person here? So the intent of that phrase is to find out the most emotional person. And the happiness is the emotion entity. So the word happiest maps to happiness. This next phrase, who's the least angry person, you might say. That's the intent there is to find the least emotional person with the emotion of angry, which could have been happiness, could have been sadness, etc. The next one is sorted by emotion. So show me all the scared people, all the fearful people. It would choose that emotion and sort them by that emotion. The other one that's not up here is show me the third most surprised. So when that's to look for a specific person in the list. So it's able to understand the intent of what I'm asking for. I've used natural language. It doesn't really matter how I phrase these questions. It's able to determine what they actually mean. The way we code this application, this is some C#. Who's does C#, just by show of hands? Okay, good, a lot of you. So I'm using C# here because that's what I use. It could be JavaScript. It could be some other language. It doesn't matter. Hopefully this will look quite familiar for those of you that do C#. So the way this app works is I upload the file, the image. I've got an API endpoint there, just like a regular API. I just use a regular HTTP client. I add this thing called an OCP subscription header. This is basically the API key. So all of the cognitive services have that API key, and I add that in there. I then stream the content. I say it's something called an octet stream, and it gives me a JSON result set back. And I just do something with that JSON result set. I won't go through the details of exactly how that works. I convert it using JSON.NET to a list of faces, basically. A face is a strongly typed .NET object that I'm working with. Once I've got my list of faces, I then need to get the Lewis intent. So what do I want to do with these faces? Same thing, there's an endpoint there. I set up a HTTP client, I've got my subscription key, and then I pass in this thing called a Lewis query, which is the bit of text that I typed into that text box there. It gives me some JSON back. And then I extract the emotion intent from that JSON and use that to sort the list of faces. And that's how I can sort the list of faces shown on screen. Very, very simple. The reason I've shown you that is because it's really simple. They're just APIs. There's nothing, you don't need any special software on your application. It's just a standard API call. If I was doing this in Angular, it would be however you normally call APIs in Angular. If it was in jQuery, it would be however you normally do it in jQuery. It doesn't matter. It's just an API. The final one I want to look at is a recommendations API. So this one is very good. Is anybody in e-commerce? Just by show of hands. Does anything with e-commerce? Just a few of you. So this hopefully will be really useful for you. So this gives you that item-to-item, frequently brought together recommendations type technology that you see on the big e-commerce sites. But it does it with your inventory and with your usage data. So what I want to show next is an example of this. So one of the APIs in our list here is the recommendations API. And this does, like I say, it does frequently bought together. So people that bought this also bought this. Item-to-item recommendations. So this item goes particularly well with that item. Like this pair of jeans goes well with that T-shirt, for example. And it also does personalized user recommendations as well. The way you use this is you have a data set. So I've got a data set here with a load of books in it. So these are books. Each book has an ID. It has a title. They're all the category of book. And then there's some extra data here as well. So I've got author, publisher, and the year the book was published. It's just a CSV file. I've also got another CSV file with some usage data. So this is basically user IDs and book IDs. So the first one is the user ID, the second one is the book ID. So this is telling me which users use which books. And using just those 2 bits of data, I'm able to build a machine learning model that makes those associations of which books go together and which books don't. The way I do that is I go to something called the Recommendations UI. I've already created the project there, the books project. I've already uploaded the catalog and my usage files, and I create something called a build. What a build is basically where it takes all of that data and comes up with the recommendations model. So again, we're coming up with a model here that I can test new data with. What's important with this one is that you can have multiple builds. So in a real-world scenario where you actually, if you've got an e-commerce store, this stuff might change according to season, according to what the weather's doing. You might want to do a new build of this every day because your recommendations are going to change every day based on what's going on in the real world and the promotions and all that kind of stuff. So you can update new builds, and each build has this ID. Now, all I need to be able to call this is the build ID, the model ID for the actual model that I'm going to use, and then I just use the API reference to actually call into it. So what I'm going to do now is go to the API reference. There's a load of APIs for this one. A lot of them are to do with managing the builds. The one that I'm interested in terms of actually getting recommendations is this one called Get Item to Item Recommendations. Most of the APIs in cognitive services have a thing called an API test console, which is a little web interface that you can literally test the API with your data, with your keys, and all the rest of it. So I'm going to just put in some data here. So the model ID is this guy here. The items I'm going to look for, I've got the item code for the Lion, the Witch, and the Wardrobe, so we're going to put that in. I'm going to say I want 5 results back. The minimal score I'm going to set to 0. The build ID I'm going to set to this one here. Now, if you don't pass the build ID, it will just use what's called the active build, which is the most recent one. And then finally, I need this subscription key as well, which we can get, which is the same for any cognitive service. We put all that in. Do send, it's actually going to make the request using my real data, so that's giving me a 200 OK. And it said these are the recommendations for that particular title. So Prince Caspian has got a 66% recommendation, Horse and His Boy has got a 65% recommendation, and so on and so on. So hopefully you can see that that's a very useful data set. Now to finish this off, we've got a website, which again you can look at this yourself if you want to. It's http recommendations API.Azure websites. I'm going to blog about this probably next week. So if you follow me on Twitter, you'll get links to all of this stuff. And there's a GitHub with this on as well. It's recommendations probably. So this is just a very, very simple, again, it's ASP.NET because that's what I know, but it wouldn't have to be. Very simple site using that same data set. There's all the books. Probably don't do this in terms of UI, like having 2,000 books as bits of string on one page. But I can click into any of these books, and it's going to go and make that call to those 2 APIs and get me item-to-item recommendations and also frequently brought together. So this one doesn't have any frequently brought together, so let's click into a different one. There we go. So that one doesn't either. Keep going until we find one. There we go. So this book, based on that data set and that usage, has got these item-to-item recommendations and these frequently brought together recommendations. All I've done there is a simple API call. I've built the model based on my own data and done some cool stuff with that. So just to wrap this up, I've shown you a lot of silly demos now. This is a video of something, a guy at Microsoft who's visually impaired. He's been blind since the age of 7, and he's used this to build some really useful applications that kind of make his life better, and it's just a quick video, it's all about it.
I'm Sakib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers. And that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before, and in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So there we go. So that's quite a nice example of, we've looked at twins or not and all these silly examples. That's actually a real-world example that's really making a difference for Saqib's general life there. So thank you very much. We've covered a lot there. Machine learning in general. What are some of the principles? It's all about data. It's all about patterns in data. We've looked at the machine learning service, which is the software that we've got in the cloud that helps you build those machine learning experiments with your own data. And if you don't want to do any of that stuff, you just want to get some of the benefits of machine learning, we've got the cognitive services set there. And there's a bunch of APIs with a bunch of stuff that you can look at there. So thank you very much. My name's Martin Kearn. You can tweet me and email me. If you go to this URL at the bottom here, you'll get the slides for this and various other links as well. So feel free to contact me. I'm happy to take questions now, but I know we are over time. So maybe tweet me those. And also, please do feed out do the little thing when you exit there. Use the voting cards. If you've got detailed feedback, please contact me. Was this detailed enough? Was it too technical? Was it not technical enough? I do this talk quite a lot, so I'm happy to adjust based on feedback. And I just seem to love the colour green. I don't know what it is, but I just seem to love the colour green there. So thank you very much. Thanks for your time, and I'll be happy to take any questions.